Hi my friends, today we model this shift metal part object with the name cylinder support. The drawing is here. I hope I didn't forget any dimension. We start with this ring, which is defined here. Diameter external 425, internal 8 holes of 14 placed on this diameter of 394. Don't ignore the 22.5 degrees angle for the first hole. You also must consider that the part has a cut here. You see? This. Dimensions are 180 with 20. This is the cut. You see? Because the dimension is 240 here, and this is subtracted from 240. New sheet metal, XY plane, circle, .425. The other circle is 365.5. I draw two lines. 1, 2, 3 lines. I make them equal, the sides, and this means that it is centered here. Dimensions are 360, and from the circle to the base 240. Trim this arc, and we add that cut. I apply split. I apply construction to this segment, equal the two, and dimension of 180 here. Now we take a look at the thickness, and you see the thickness is 10 millimeters. Very great. Okay, we go to the defaults of the sheet metal. We ignore the default value and we change it with 10. Everything will depend on this 10 from now on. Starting with the face, with this face, which has a thickness of 10. Good. And now that 8 holes, sketch line from the center to somewhere here, this distance is half of 394. 394 divided by 2. I project the vertical, which is the axis Y, and I place the angle of 22.5 degrees. I place a point at the end of the line. You see, I don't make this construction, nothing, because only this point is useful for the tool hole. Then circular pattern of this very point about this very center, not 6 but 8 instances. Finish sketch. You see we have the tool hole here in the sheet metal environment. Hole, you see, all are automatically selected. The diameter is 14. Okay, now you see we have two flanges, these two, based on that two edges of the base of the ring. Dimension is 33. You must know that I'll place here 310 because I will start with an arc here, so that this 330 will be 330 minus twice thickness. Flange, edge, and another edge. This solution, because I include both this face and the bottom. The length is 330 minus twice thickness, major T. Be careful. Thickness. Now it is black, not red. Okay. The distance I measure, M from Monaco, is 310, and we'll continue with another radius there, which is also twice thickness. Good. Now we see that there is a connection here between the two flanges. The connection is defined, the width of that connection is defined by these two bent. Yes? What means this? This means that the dimension is 80. If I place here a dimension, you see that this is 80. You see? Because this end is a continuation of this. We create that connection by using 80 minus twice the thickness. Yes, we'll obtain this distance between the two. Okay, let's create this face. This will be a face. I draw a rectangle from this point to this point. Tab, and this dimension is, as I said, 80 minus twice of thickness. Which means 60. Face, select. Okay, next is this side flange, this one, which has the dimension of 110. It is placed from here to here exactly as this edge is. Flange, you see what is the solution, and I write here 110. Okay, now I add here a face in order to cover this gap. You see right here that there is an extension here. The dimension is this with 1 millimeter gap instead of let me see, 10, so that we place here 9. Okay, at an angle of 45. Good. Let's do this. The face is here. We draw a line to the right of 10 minus 1 millimeters, and we go back to the end of this line. The angle is 45. Fully constrained. Face this area. Okay. Good. For rigor, I should have included the thickness instead of a value of 10. I can do this here. Thickness minus 1 millimeter. It is the same value. Then we place another flange, which is this one, 99, again a distance of 1 millimeter, which is this, 99. flange, flange, internal 99, but we select the other bend position. You see how it is now and how it will be. It is outside to the left of this end. Okay. We apply mirror for this last three features about the plane YZ. Okay, now M from Monaco, and we measure this distance to see that it is 330. Now this flange, which is starting from here, from that connection, as I said. What is the dimension? 180. We apply flange, this edge, we go back here and 180. Okay. You can measure this and we see that this is 160 and the distance between these two is 162. There is a gap of 1 millimeter at each sides. Then the other flange of 80, as you know, 80 with the same bend position. Okay, then we want to create this combination of one flange up, one sloped, another one, all of them having the same width, 160, like this one. Remember dimensions here, because we use now contour flange instead of flange, simple flange. You see, this is a radius, this is another, this is a vertical with dimension of 152, then another radius, a distance horizontal, a line of 90, a radius 30, and 19 from the center. This length is 120. What are the radii? Because they are not dimensioned. Well, this is, you know, this is the bend radius with the value of 10. This is the thickness. The thickness is also 10. This means that this radius is external, which means twice thickness. This one is internal, this one is internal. They are the same. What is the radius for both is thickness. Okay, let's create this contour. External all over. External, not external, to the left, yes, and to the bottom here and up here. Okay, we select the plane YZ, F7, we project this line and we make it construction and we draw that contour line, not arc, starting from here to up, just at this end, but I don't place it there. I go up, I keep pressed the left button, I go to the left, sloped, tangent as much as I can reach points, horizontal, radius half of a circle, line, radius here, and we end somewhere here. Tangencies. This is tangent with this, this here, and I suppose this. Good. This radius is taken from the parameters. Thickness is this. Okay. This is equal to this. And then we have here another situation with twice thickness. Thickness multiplied by 2. Okay. The distance is 152 is from this line to this center. 152. This is an angle of 30. Its length is 120. This from this line to here is 235. This radius is 30 as in the drawing. This is equal to the other. Also 30, and from the center to down, which means this line, is 19. One dimension needed. Which one? This one. This is 90. Okay, we use this contour to apply contour flange. It is selected, already selected, and I have to see which solution. But before we select the edge, type is edge, I have to select this, and this is okay. But the width is 150 60. You see, I don't see this. I don't select this, which means some not what we expect. To fix the width, we go to width, which is centered, and the value is 160. Okay. Now we take a look at the drawing and we see here a hole. Yes, this hole. The distance is 520 and the diameter is missing. My fault. Dimension 60, my friends. This is the first missing dimension in my drawing. Nobody is perfect. 520, diameter of 60. We select this face to create a new sketch, F7, and we draw a line from this point, center point or projection of the center point to here, and you see 520. Okay, point at the end, and everybody is happy, fully constrained. Finish sketch, hole, 60 through. Okay, other holes are this 6. You see 46, 220, 250, and a diameter of 27. Let's create these holes. We start with a sketch, of course. F7. Line from this point to this point. 46 from external, so that I need to project that external. No problem with the F7. I don't know if where it comes, so I project this face, whole face there, and now F7. This is the line. Yes, 26, not 26, 46. 46, then the length of 220, the distance to the projection. No, we have the midpoint, the center point here. Dimension from this to the center point is half of 250. 250 divided by 2, as you can see. Then I place 3 points. 1, 2, 3 in the middle. Finish sketch, hole, diameter of 27. Okay. You see the 3 holes. Then I mirror them, all of them. By using the plane Y, Z. You see? Okay. The last are 2 threaded holes. This 2, 1, 2, metric 16, distance of 104, distance of 290. Let's create these 2 holes. Face, sketch, line, line here, 104, distance of 290 to the end, 290, F7. Now we have the center point to place the midpoint of the line on the same vertical. Then 2 points at the ends of the line. 1, 2. Finish sketch, hole, threaded, metric 16, and full depth, but not through, because they end here, not through. Okay, let me move this. Okay, now I apply the procedure presented in my previous tutorial to expand all children. Why? Because I want to see if sketches are fully constrained. Oh, I see here that this is not fully constrained. Double click. Yes, 1 dimension needed. What dimension? This line. Voila. This is 20, if you remember. Finish sketch. This is the new. And the other sketches only. All of them are fully constrained. Yes? Okay. Very good. Then I make collapse all of them. This is not a rule, yes, to have fully constrained all the sketches. For instance, in a recent tutorial, I had drawn a line for a rib, if you remember. That line was not ended because its direction and position is important, not the length. So you have to verify. Now let's see what is the volume of our production. Physical update, copy, close, drawing, double click, paste. What do we see here? We see here something not significant. I eliminate the former result in exchange with this. Yes, this is what we made together. Okay. Remember that in my initial drawing I didn't place this diameter and this dimension for the holes, for your knowledge. Material, steel carbon, semi-polished, and this is the part. That's all for today. Thanks for watching. Bye bye.